In this lecture, we are going to look into the complement representations and the sign magnitude and the complement representations in other number systems apart from binary, like the octal, hexadecimal, as well as the decimal. So let us go ahead straight into it. So the octal sign magnitude. The octal sign magnitude. So in the octal system, you know that there are 8 bits, 8 digits, and we know that the MSD, the most significant digit, is representing the sign. To represent the sign, we have option to select from 8 of the digits. Here, the first 4 digits are chosen to represent the positive numbers, and the last 4 are chosen to represent the negative numbers. So any one of 0 to 3 can represent your positive numbers, and any digit from 4 to 7 can represent your negative numbers. So this should be actually D, not B, because we are talking about digits. So the remaining digits would give you the magnitude. So we suppose that we are having a n digit number, n digit sign magnitude, octal sign magnitude, and hence the MSD, if the MSD is between 0 to 3, it is a positive number. If it is from 4 to 7, it is a negative number. So and the rest of the digits, rest of the n minus 1 digits gives us the magnitude. You can see a very simple example is there. If we have to represent the quantity plus 85 in 8 sign magnitude, so first we need to evaluate what 85 is in octal. So if you do the evaluation, you will see it is 1 to 5. So this 1 to 5 forms the magnitude part. As you can see, in all the numbers this is same. However, in the top row of numbers are the positive numbers, so your MSD could be 0 or 1 or 2 or 3. All are same, all are equal, all are equal. Similarly, for minus 85, if you can place 4 or 5 or 6 or 7, it does not matter. So this is about the sign magnitude representation. When you come to the radix and complement radix representation, what we are talking about for octal, we are talking about the 7 complement and 8 complement. Same thing is happening. The most significant digit can be from 0 to 3 being positive, 4 to 7 being negative. That is absolutely fine even in 7's complement representation and 8's complement representation. However, the caution is this, that if you want to do any arithmetic operation with this in this representation, then you have to convert the MSD. I have kept, I think, B everywhere in this slide, so that would be MSD, because we are talking about digits now. So we have to convert the MSD to the extreme value. If you want to do any operation, any arithmetic operation, you have to use the MSD either 0 or 7. 0 for positive numbers, 7 for negative numbers. So you have to extremize this. Otherwise, we have experienced that the result is not always giving the correct answer. However, if you keep them at the extreme digits, the result will always come out to be correct. The same other things remain the same. If you want to find the negative number, that is the complement representation of a negative quantity, we have to take the 7 or 8 complement of the corresponding positive number, and the positive number is the same as the signed magnitude positive number. So if you want to take the represent minus 85, you have to look for plus 85 first, and in sign magnitude you have seen that it is this. I am keeping this as 0 because I would be I hope that I will be doing some operation. So now what I need to do is I need to simply look at the complement of this number. So if I am doing the sevens complement, then I am only taking the complement of these bits or of these digits, and that's all. And if I do that, I will be landing on 7652. If I am doing the eights complement, so this is the 7 complement representation of minus 85. If I do the eights complement, what I will get, I'll only have to add a 1 to this, and that gives me 7653, which is the eights complement representation of minus 85. That is the thing. Then you do the operations in the complement representation. So you do your operations in the complement representation. So you do your addition. So if you want to subtract 85 from some quantity, you take this particular number. If it is in sevens complement, if it is in eights complement, you take this particular number, you do the addition, and the result will come out in the corresponding representation system. If you are working in sevens complement, it would come in sevens complement representation. If you are working in eights complement, it will come out in eights complement representation. You take care of the overflow. If there is an overflow in eights complement, you discard that overflow. If there is a complement in, if there is overflow in sevens complement, you have to add that overflow back to the result. Then you interpret the result. You look at the MSD, decide whether it is a positive quantity or a negative quantity, and find out the magnitude of that quantity. If it is a positive quantity, you have to only look at the remaining digits and evaluate the quantity. If it is a negative quantity, you have to take a complement and come to the positive number, and then evaluate the magnitude. So in that way you can do it. So it is the same process. So the process does not change. So maybe I can do an example here, like minus 85 is this. Let me see what would be 80. Let me subtract this from 86, say. So 86 or 87, say. Then I would get an answer of 2. So if 0125 is plus 85, then 87 is basically 0127. And let me work in sevens complement representation. Suppose first I work in sevens complement representation. So I am I have this particular number to subtract to add with 0127. I am doing the addition operation opposite. In order to save space, I am putting the result here. So what you get here, 7 plus 2, 9, which is 1 and 1 carry. Again you get 7 plus 1 is 8, which is 0 and 1 carry. 7 plus 1 8, which is 0 and 1 carry. 7 plus 1 8, which is 0 and 1 carry. What you get here, you get an overflow. So the overflow you will discard, since you are working in 4-digit number. So the overflow so you are not discarding the overflow. Please don't make a mistake like I am doing. So you are working in sevens complement representation. This is the diminished radix representation. In diminished radix, you are taking the overflow back and adding it to the number. So you are adding it to the result, and hence what you will get is basically 0 0 0 2. So the value would be 2. So this is a positive quantity, of course, and the value is 2. That is what we should have got, because we are doing 87 minus 85. And for the in 8's complement representation, the positive quantity remains the same. The negative quantity is represented like 7653 in this case. This is the 8's complement representation of minus 85. Now we do the addition. This is 10, that means this is 1 2, 1 is carry, this is 8 which is 0, and 1 is in carry 0, 1 is in carry 0 and 1. And since this is in 8's complement representation, the overflow that we have has to be discarded, and the remaining number gives you the actual result. And here you see, look at the MSD, it is positive, and the magnitude, you look, it is 2. So I hope that is understood. Let me show you an example where we are subtracting a larger number from a smaller number. So here we subtracted 85 from 87. Let us subtract 85 from 83, or maybe 80. Okay, so 80 will be 120, I guess. Is 64 plus 60, yeah, minus 5, the same. So but this 85 is same, minus 85 is still the same, so I don't have to recalculate this. That is why I am choosing minus 85 always, because I don't have to do the recalculation. But what happened to 80? So 80 is 0120. So again, let me do it the opposite way here. So I am adding this to, so what I am doing is I am doing 80 minus 85, right? So this is 80 and this is 85, 80 in 7 CR. So now I am adding, what I am getting is this is what I am getting. So did I get any overflow? No, I did not get any overflow. So this is my, this is the 7 complement representation of the result. So now I have to look at the MSD. MSD is 7. So it is a negative quantity. Minus, you put already down. But you have to know the magnitude. So to know the magnitude, you have to take the 7's complement of this number and find out the corresponding positive number. And when you do that, very easily it comes out to be 5. So the magnitude you can evaluate from there, and you get minus 5, the result. Similarly, you can do it in 8's complement representation. So when you add these things up, what you are getting is this. There is no overflow, so this is your MSD to be considered, which is minus. So you put a minus in the result, and then you have to figure out the magnitude. So you take a 8's complement here, and when you take the 8's complement, what you are doing is you are taking the complement of the digits and then adding the 1. Don't forget to add the 1, and when you do that, you will again get this, and the magnitude would be 5. Minus 5 is your answer. So I hope you got it. So I will not repeat this process for the other number systems. You can pick any quantity you like and work out for your own practice in the other complement representation systems also. However, again, very important, keep this in mind, you should not choose quantities, you should not choose values which gives you a result which lies outside the operating range of the complement representation chosen. So please keep that in your mind. Decimal sign magnitude, same, the same concept. There are now 10 digits, so 0 to 4 would be the positive, would be for positive numbers, 5 to 9 would be for negative numbers. So if you see a 0 to 4 in the MSD, they would be positive numbers. If you see 0, if you see 5 to 9 in the MSD, they would be negative numbers, and the rest of the digits would give you the quantity, it would give you the value, it will give you the quantity. So you can see the example, pretty straightforward. When you are doing the 9 and 10's complement representation, then also the concept remains the same. However, if you have to do any operation, so you have to extremize the MSD. So either you choose 0 for positive, you choose 0 for negative, you choose 9, then you do the operation. So in the same manner you have to do the operation as has been illustrated in the previous lecture in binary. In just now also I illustrated for octal. In the same way you have to do it. You have to take the complement representation of the quantities that you need to add. So if it is a negative quantity, you have to take the complement representation of the negative quantity. If it is a positive quantity, you have to take the complement representation of the positive quantity. By now you should know what is the complement representation of the positive quantity and what is the complement representation of negative quantity. You should know this, how to evaluate them. So after getting these representations, you simply add using the normal addition rule, and what you get is the result in the corresponding complement representation system. You have to look at the result, you have to see whether there is an overflow or not and deal with the overflow accordingly. So if it is a 9's complement representation, you add the overflow back to the result. If it is 10's complement, you discard the overflow, and then you look at the result, you look at the MSD, understand whether it is positive, negative, and then accordingly you also find out the magnitude of the quantity. Same thing happens for hexadecimal sign magnitude, and here 0 to 7 are the positive, are the digits representing positive numbers, and 8 to F for negative numbers. So if you find them in the MSD, you should understand what is the sign of the number, and correspondingly there is a 15 complement and 16 complement representation, and the same way it goes. To do any operation you have to take either 0 or F, 0 for positive, F for negative, and the other things remain the same. So with that, actually this lecture ends, and you take some numbers like this 85, that this number only you can take, and you can take some 80, 82, 81 like this nearby numbers, or even 50 like the faraway numbers also you can take, and you can check whether the algorithm is giving the correct result or not. So this is where I will leave you in this lecture, and practice some on your own, keeping in mind that you should not choose numbers whose result is outside the range of operation. So keep that in mind, and then you can take any number, you just apply the algorithm, the result would definitely come out to be correct. If it is not coming out to be correct, then you have done a mistake. So please check back on your own calculations and application of the algorithm. The algorithm is solid, the algorithm is absolutely it works for all numbers provided you have chosen them within the operating range. So with that I will leave you, and hoping that you would practice something on your own. and there can be many questions coming in, which I will take up in the live sessions. If there is any doubt, if there is any clarity to be provided, if there is any further conceptual questions also, there are some conceptual bits which I have left out intentionally because they are not so much pertinent for the course. But if you have any such queries coming up in your mind, please post them to me, post them beforehand probably, so that I can prepare myself, and then I can resolve those queries also in the live sessions. So unless you ask those queries, I will not go into those queries, um, because they are not so useful for this particular course. But if someone of you raise some queries, definitely that would be addressed. So with this, I will leave you, and thanks for your attention. And so so this actually also ends um, the operations using signed numbers. So uh, there would be actually an assignment on class notes which you have to make. So I hope that you are already preparing your notes, and when it comes up, then you would be ready to submit it. So with that, I will end the lecture. Thank you for your attention.